Okay, welcome everyone. Thank you for coming to this session. The name of it was generated by ChatGPT, but the contents are mine. My name is Martin. As you may guess from either my name or my Eastern European accent, I'm from Slovakia. I work as an architect at Moro Systems, and I love to travel. I wrote myself this app so I know where I've been and can keep track of it, and found out that Prague is my most visited city. So always means an adventure for me. Let's go for one adventure together. Enough about me. I'd like to ask you, guys, who of you either runs an application in cloud or develops an app for cloud? Who is in cloud here? All right, about everyone. Who goes beyond Kubernetes to infrastructure, to stuff like managing network, storage, stuff like that? Again, almost everyone. Who uses Terraform to manage their infrastructure? Okay, everyone. And Pulumi? 3 people, 4, all right. So I hope to show those using Terraform what the benefits of using Pulumi would be. I'm gonna go really fast through this, as most of you do use infrastructure as code already. But when you ask ChatGPT what a team that doesn't do that look like, you can get this. So a lot of documentation out there, a lot of despair, production incident happening at the moment. As you can imagine, this slide is for the teams that do use infrastructure as code. So everything is nice and green. Again, for those not familiar with the concept, instead of you going to Azure Cloud and creating a new SQL server for yourself by clicking new server, filling in all of the attributes, you just write yourself code like this. This is from Terraform. You run a command, and what it does, it compares your code base with what is in the cloud. If the SQL server is not there, it spins one up for you. If it is there, but in a different configuration, it updates it. And also, if there is already the server in the exact configuration as you want it to be, so it matches your code, nothing is done. Disclaimer first, I allow everything as code. You can see that even my presentation is written as code in Reveal.js, so I'm a bit biased here. But what I like about infrastructure as code is that it is reusable. As you saw that I can create my database through writing code, then it's easy for me to apply this for other environments as well. Also, there's no need, in my opinion, for additional documentation. What you saw is readable, is there, and yeah. You also have guaranteed that it's up to date. As I mentioned, you can have diffs being done, whether so you see whether there is some drift in your configuration and what is in the cloud. And if you set up your pipelines well, you can be guaranteed that what you see in the code is what you have in the cloud. Also, it's versioned. You can take a look at why the incident that happened a month ago did happen and what the state of the infrastructure was at that time. And you can put in good use all of your development practices that you have when developing apps, also for infrastructure. So merge requests, code reviews, stuff like that. When you Google, I want an infrastructure as code tool, the first response that you're probably gonna get is Terraform. Another disclaimer is in place. I loved Terraform. I think it was a great stepping stone for other infrastructure as code tools that came after it. I think there's a great community around it, and still the most used infrastructure as code tool at the moment. And there's a huge ecosystem of tools. So you want to check your costs and track your costs in the cloud. You want to check your security. You want to pay attention to have some policies in place. So there's plenty of tools for you to use with Terraform. As you probably guessed from the name of the presentation, we're going to be talking about Pulumi. I have to admit that when using Pulumi, the ecosystem is not there yet. For example, InfraCost, which is, by the way, a great FinOps tool, has Pulumi on its timeline for things to implement, but it's not there yet. Okay, so why would you even consider switching from Terraform to something else? What I have here is actual production code from one of my projects, and it is a bit simplified for the purpose of the presentation, but it's real code. If you want to conditionally set up an Azure Active Directory group, or it's called Entra ID now, if you want to do that, you're using count with some ternary operator. So far, so good. But when you have to want an conditional attribute owners set up, you have to do this stuff. There's no more count. You have to have a for each. That for each will produce either an empty array or an array of one element. That element is completely arbitrary. There could be hello KCD there, and it would do the same thing. It's there just for the purpose of executing that code. When you want to extend some array, let's say that you have users that you want to have to be owners of this group in an array. You want to add one to it, you have to concatenate two arrays. There's nothing for like adding a single element to an existing array. If you want to print out what the just created group's ID is, you have to use this, like an asterisk operator or index to access the possibly created, not created object ID. And Terraform actually cannot output something that is nullish. You have to join it with an empty string for you to be able to even run the Terraform program. So I don't know what about you guys. I don't really think this is a nice code. So here comes Pulumi. What you see is my Pulumi program, the same kind of snippet, just rewritten in Pulumi, using TypeScript. So I like to have my variables set at the start of the program. That's what you see behind me. Then, if you want to conditionally set up the group, use an if statement. Everybody understands what an if statement is. You don't need to learn anything about counts or for eaches and stuff like that. Also, you want to have a conditionally set owners. Use ternary operator with undefined if they should be undefined. You have regular TypeScript code. Also, want to conditionally export that ID of the just created group. You have an operator in JavaScript for that, so why to reinvent the wheel? I already mentioned to you that probably the purpose of this presentation will be showcasing you Pulumi, which is an open source tool. Terraform is not so open source anymore. Instead of writing in a proprietary language, which HashiCorp does, HashiCorp's language, you use some of the supported languages, including TypeScript that I'm going to be using in my demo. I think simple contracts should be simple. That's what the comparison between those two snippets was about. And when you are using a standard language and you know it well, you can use all of the tools that you use when developing apps. So you have your IDE support for auto-completion, for checking whether something that is required is being specified. You can use linters, pre-tiers that you have for your regular apps, also for infrastructure. Okay, I like to live on the edge, so I have a demo. The demo is dependent on network, response time of the server, and some AI, so anything can go wrong. But it will be fun for you to see me struggling here and trying to make it work. I'm starting a new project. There's nothing here. Yeah, it's just my ID settings. So when we want to start, we are going to create a new Pulumi program. So my cloud of preference is GCP. That's why I'm choosing it. And I have to force it because there's already something in my folder. And Pulumi complains when there is something. Okay, project name can be the same as our directory. We don't really care about description. Stacks. Simply said, or to simplify things, let's say that stacks are your environments. So let's start with the dev environment in Pulumi. Yeah, and I won't be putting in any Google Cloud Project ID to deploy to, because you can actually use infrastructure as code for creating a project in the cloud. What is happening at the moment, for those of you familiar with JavaScript development, is that dependencies are being installed through Node Package Manager. So there's no magic here, really. If we see what was generated for us, we have a simple package JSON. The dependencies here For those of you familiar with Terraform and providers there, the same concept applies in Pulumi. You have your providers. A provider is a plugin that contains all of the resources for working with the specific cloud, let's say. In this case, GCP. I have some of my configuration. You could put variables in here, TypeScript configuration, but that's it. There's no magic here. We have some example code here. Let's delete that. And let's have in this file, what we're going to do is we're going to create a new Kubernetes cluster in GCP. That's going to be the contents of the first half of the demo. I do like to use GitHub Copilot. You're going to see that a lot in my demo, and it's going to make things faster for me. So let's have a project ID like this. I have my organization ID and billing account in environment variables for obvious reasons. In Google Cloud, when you want to use some resource like Kubernetes cluster, you first have to have the API enabled for you to being able to create one. So for creating GCP, a cluster in GCP, we first have to enable Kubernetes service. You're gonna see the first example or first concept of infrastructure as code that as an input for one resource, for the resource of creating a new service, you need project ID. That project ID can be a reference to another resource that you created before. Now we are ready to create the cluster. What do we have here? Okay, so we're gonna have a zonal cluster of one node. I wanted to make things really simple so it's easy to go through the code and keep up to speed. Of course, there's plenty of stuff that you could configure here. One node is in place. Most of the time, like 95% of time, infrastructure as code tools, both Terraform and Pulumi, know what your dependencies are. So Terraform is a declarative language, or HashiCorp language is a declarative one. Pulumi works imperatively. It doesn't mean that when the program is run, that the project is created at the line 4 when it is executing. That also applies to the fact that the order of the resources being created is not the order that you see them in those files, in your scripts. What it does is, when it's running the program, it just registers it and then creates a graph of all of the dependencies, all of the resources, and knows in which order to actually create them or update them. The problem is when it is not evident for the Pulumi program that there is some dependency. For example, the fact that you have to have an API enabled before you try to do something with the service is something that is unfortunately not visible to the program, and so you have to provide that information yourself for the dependency. But I'd say 95% of the times you won't need to do that manually. Now, what I can do is run a command that does the diff between my source code and what is out there. What we should see is 3 resources plus 1 for the Pulumi program being created. Yeah, you can see it here. And if I run yes, what it does, it starts spinning up my Google Cloud project. I'm gonna be cheating here a bit. It takes some time for the cluster to be spun up in Google Cloud, and we don't have that much time. I have another project here that is completely identical to the one that I was just working on. I simply had it already applied, so I have cluster up and running, and we can move to another stuff. The next stuff will be, when we have a cluster, we probably don't have it because we just like having clusters, but we want to deploy something to it. Let's have a Hello World app deployed to a cluster, and let's have it exposed on some public IP address. So, first of all, I already mentioned to you that we are using providers for working with resources. When moving from the Google world to the world of Kubernetes, we need another provider. So what we are going to do is install a new dependency, and that's going to be a Kubernetes provider. Let's do that. While it's installing, we can import it. Yeah, that's the one. I think we won't need the terminal for a moment here. Let's create the Kubernetes provider. That's a bit weird name. It takes a single argument of kubeconfig. So how do we provide the kubeconfig? Unfortunately, at the moment, there is no utility in the provider for you to easily create a kubeconfig. So I have this live template in my IDE always at hand, but it doesn't do any magic. For those of you familiar with how kubeconfig looks like, you know, it is this. It's simply interpolating information of just created cluster into that kubeconfig. So this is something that you'd probably have in some utility file or something like that. Now I can reference it, and I have my provider. Now let's create a resource to it. There was a bracket missing. So let's have a deployment there. So for the deployment, there's going to be just really a simple case of hello world. I want to have an app that exposes a REST endpoint that I can call, and it returns hello world to me. I found some, let's say, random image out there on Docker Hub that does what I want to do. It's not mine, so it can go down at any moment. I told you I like living on the edge. It exposes the REST endpoint and 50/50. And some of the stuff that you can do here is, okay, so we have some repetition of our labels here. So let's extract that to labels. You are in a, let's say, normal programming language. You can do the normal stuff that you would do when developing apps. I think that's all right. That's enough for the deployment. Let's have a service now created. Sorry, okay. The autocomplete was faster than even my attention. So we have a service here. Yeah, we can reuse the labels again. Why not? What we can do here, again, we could have that target port extracted in some kind of variable. But another thing that we can do is we can reference the just created deployment. So let's go to deployment. Let's find it in the spec, that container port. Now we are sure that when someone comes and changes our deployment code, it is also affecting the service, so everything is still working. We don't want to have load balancer type here, but node port, because that is necessary for the G-key cluster and the default ingress to be able to forward our messages. All right. What I want to do is I want to have a public static IP address created in the GCP. Now we are again in a state when what we wanted to do with Kubernetes is kind of done. We now need something from the GCP. So let's create a new global address resource from GCP. What it does, it reserves an IP address for us. And now we can hop on back to the Kubernetes and create an ingress for us. So let's hope that it knows what I want to do and makes it simple for me. Okay, it does. So I can reference the just created IP address in annotation for the Kubernetes resource. Also, I have some rules here. I don't want those to be there really. I want to simplify things, so just have a default backend, and for it to forward all of my requests to the single service that we have. Again, referencing it from the earlier. Let's now pause for a moment, because there's one last thing missing. We want to actually see what the IP address is so we can access it. We don't want to have name here. We want to have the actual address. I think that should be all. So now when I run Pulumi up, we should see that that cluster is already created and in place, so it shouldn't be created from a new. And also, we should see that those things that we want to deploy into the cluster should be declared as new ones. Yeah, 4 unchained resources, 5 to create. We want to do that. There's no more cheating at this moment. I'm actually doing that. But it also takes some time. What we're going to do is we're going to cover some concepts that you could see and maybe missed what their purpose is or what the benefits are when working both with Pulumi and Kubernetes. So first of all, you saw that I had a provider for GCP, created a cluster, and then used the output for creating a new provider, a dynamic provider of Kubernetes. That is something that you cannot do in Terraform. You cannot both create a cluster and deploy to it in a single program. Also, you probably don't want to have everything in one place. So you saw that I only used one index file. Of course, you're going to separate your resources into multiple files, but you don't have to stop at that moment. You can have multiple projects. They don't even have to live in the same Git repository, see each other like on the file system. They will be synchronized through a state. And you can have infrastructure separated. You can have a separate team working and deploying, preparing infrastructure for you, then exporting some of the variables of just creating infrastructure for those development teams for them to inject them and use them in deploying their apps. Also, I'm not really a fan of working with Kustomize. Whenever I work with Kustomize and wanted to have some custom settings for different environments, I ended up with having a base layer and then having layers for every environment, applying some patches. So you use YAML patch because you already have YAMLs, so you want to be on the same page, but then you find out that in Kustomize there's a limitation on how many characters a YAML patch can have, so you switch to JSON patch, and now you have a bunch of stuff there that you have to understand how it works. This is something that you don't have here. And also one of the, let's say, side effects really of working with Pulumi is that Pulumi tries to work with the infrastructure as in a zero downtime manner. That means that those names that you see in my program, for example, that there's a name for ingress that is hello world, I think that's REST, yeah, REST. It's not the actual name that's going to be applied in the cloud. Pulumi does append a hash at the end of it. So whenever a resource changes, it does the hash does change, and therefore stuff like when you update the config map, you probably want to update deployment as well. You get kind of free, but it's just a small touch. Pulumi is backwards compatible and Terraform friendly. What I mean by that is that Pulumi knows that everybody uses Terraform or was using Terraform before they came. And there's a bunch of providers already done. So instead of writing their own, and there are own Pulumi providers, they have this bridge. So when there is a Terraform provider there, you can use it in Pulumi as well. So no need for you to worry when switching from one to another. You can convert your Terraform files to Pulumi. The code won't be nice, as you probably expect, but I was in a situation where it was a custom module that was written in Terraform. It was hard for me to map on what should be written in Pulumi, and it did help to understand it. This one I haven't tried myself, so if you did, let me know what the experience was, and you can convert your Kubernetes code to Pulumi. Pulumi can coexist with Terraform. You can gradually move from Terraform to Pulumi as they can use a common state. And what I like about Pulumi, another of the nice things, is that if you don't have any infrastructure as code in place now, you can import your manually created resources in your cloud. When you do that in Terraform, you have to write the configuration yourself. And then you can run Terraform import. What it does is it matches those two, makes them in sync, but you have to be the ones writing the code. Pulumi does generate code for you from what is in the cloud. All of those underlying things are links, so you'll be able to click through them when you get the access to the presentation. And let me go back to the IDE. We do see that there is a successful message at the end, and there is an IP address for us. What we did was, just to reflect a bit, we had nothing. We created a Google Cloud project. We created a Kubernetes cluster in it. Then we deployed to it. We asked Google for a public static IP address, and then used it in Ingress, so everything is wired and coming through. And all done in under half an hour. So if I go to my browser here, and I go to this IP address, I told you that anything can go wrong. Maybe this is the moment, at the very end of the presentation. Sometimes it takes time for Google to wire stuff through. The Pulumi says that it's already up and running because it did everything it did. It got a successful response from the Google Cloud, but the networking in the Google takes some time. It will be the same even if you were clicking that in Google UI console. Let me refresh it once more. Okay, I do have a backup plan. I don't know if you guys use Lens. Who uses Lens or knows about Lens? Okay, great. About an hour ago, there was a presentation from Tiffany, and she showed you K9s. So this is like K9s, but an app for that outside of terminal. And so when I take a look at my cluster, yeah, you guys go and try that. It's great for inspecting clusters. And I can take a look at my deployment. It's there. Hello world. Pods are there. Let's do a bit of, yeah, let's use the service. That's going to be easier. Hello world here. Let's forward our port. So I'm cheating a bit. Maybe not doing a good advertisement for Google Cloud. But what we got is a response, hello, KCD. So everything is up and running. And now you see that even the wiring was done. So even in the Google Cloud, it works from end to end as we originally intended to do. I told you that we're going to go for an adventure here in the city of Prague. What you saw was a fight between a modern, agile robot called Pulumi and the giant that's been here for a bit longer called Terraform. Who is the winner of this battle? It's up to you. I think you know what my answer would be. Go ahead and try it. Try Pulumi. If you want to access these slides, feel free to scan the QR code behind me. Also, if there's anything that you would like to share with me, ask me, feel free to follow me or message me on LinkedIn. Also, all of the source code is already available at the GitHub. You can either link from the presentation or find it under this. Thank you for your attention. And do we have some questions?
Yes, we do. So first one valuable feature of Terraform is the plan. Does Pulumi have something similar?
Sorry, what feature? I didn't hear.
Plan. Plan. Unless it shows you what steps are going to be.
Yeah, sure. Yeah, you can have that in Pulumi. You can go into details what's gonna happen in the file. Also, you don't have to use that up command. You can separate into separate accounts to have just the preview of what is gonna happen and then apply it in the next step.
One of the biggest pain with Terraform is the state and inconsistencies with the real infrastructure. How Pulumi is approaching to this problem? Is it the same way or is it improved?
Mm-hmm. All right. So Pulumi does have a SaaS solution. You can go to pulumi.com. You can see there's a cloud variant. What they can do is they can monitor your Git repository, regularly check whether there are some drifts in the configuration, notify you if there are some. You can then also apply the deployment and do the change from the cloud, from the UI yourself. Of course, there's some fee for doing that in their cloud, but the commands, the API that is available for free is something that you can make use of, and you can have your GitHub pipelines actions doing the regular checks and notifying you if there is inconsistency.
Terraform modules already solves a lot of boilerplate and can wrap best practices for creating GKA clusters, for example. Does Pulumi have already created modules, or is it do it yourself?
Great question. I think that when I was working in Terraform, I did use, for example, for creation of GKA module already existing in the Terraform. About 1 year ago, when I was doing the same thing in Pulumi, there was no module yet for that, so I had to do that myself. I'll be honest with you, but maybe the situation changed in that 1 year.
So does Pulumi have a higher level constructs like AWS CDK?
I'm not sure I understand the question.
So I think CDK is some kind of language for infrastructure on the AWS.
Mm-hmm. All right. Maybe I'll answer the question, maybe not. Sorry for that. Feel free to catch up with me later if I didn't, because I'm unfortunately not familiar with the CDK. What Pulumi does is either the CLI or also has something called automation API, which is something that you can use as an API to stuff like spinning up completely new stacks, new environments, new projects. You can do platform engineering on this level, so you can even have a really simple service written by yourself using the SDK of Pulumi for you to be able to set up projects for your project teams, product teams, just like that.
Does Pulumi support a state file encryption as OpenTofu?
Mm-hmm. State file, it does. You can either use Pulumi Cloud as your backend, which is the most simple variant, and that's something that I have used. You also can have your custom backends, the same way as in Terraform. So for example, you can have a storage in Google Cloud and have your state there. And if you do that, you have also stuff like every stack in Pulumi gets its own directory where the state is saved at. So you can have one state for all of your environments and then apply IAM rules at the level of that cloud storage. So only someone can access dev part of the state, someone else the prod part of the state, etc. Yeah. Encryption. Yeah. All right. Sorry, as I'm hearing it and not seeing it, I don't always get the whole question. There is actually built-in encryption in Pulumi. When you want to have a custom, it is encrypted when using Pulumi Cloud. Also, when you have your custom backend, for example, in Google Cloud, Pulumi does ask you to have a key, an encryption key created in Google Cloud or some other provider for keys and secret management, and you have to specify it when creating the program, the stack in Pulumi, what your encryption key is, and then everything is encrypted.
So don't you think like Terraform pain points were mostly solved by ecosystem like TerraGrant, Atlantis, and TerraMate?
Mm-hmm. I'll be honest with you, I have tried TerraGrant, not the other two. I still kind of like the imperative style of writing. I still kind of like that I can take this code of infrastructure to my colleague that is a front-end developer, never saw infrastructure, doesn't really understand what is behind the scenes. And when I did that, my colleague told me that everything is clear to me, he understands what's happening, and I can easily have, even without adding more tools and more resources maybe in learning into the whole team, I can have something that is there, it's really simple, and anyone can understand that.
Last two questions. What about CDK for Terraform?
CDK for Terraform?
Yeah, maybe that's the same question about the AWS CDK.
Probably. Or can someone explain it further, the question? Ah, I see. I don't have experience with that. Okay, thank you. So there may be some initiative for you to be able to write imperative in Terraform. So maybe something for your homework and for me as well. So I can answer better for the next session.
Last question, and a very simple one. Can you use Pulumi for free?
Yes, you can. It's up to you how much of a convenience you want to have. Of course, you pay for convenience when using Pulumi Cloud.
That's all. Thank you, Martin.
Thank you, everyone.